Okay, so for this part, we're going to continue on with the adding and subtracting rational expressions. And we're going to take some more complex examples with unlike denominators where we have multiple binomial denominators. For the first example, I crossed out the part that exists right here just to not overcomplicate it. So we're just going to do it without that. And I'm going to state for the first step, I need to factor down the left-hand side because they're not totally factored. So I'm going to say that this is going to be the same as 4 over p plus 1, p minus 1, plus 3 over p plus 1. Now that they're fully factored, I'm going to state the non-permissibles. P cannot equal positive 1 or negative 1. I can also state the lowest common denominator is going to be p plus 1, p minus 1. Which means that the first one is already over the lowest common denominator. The second one I need to multiply by p minus 1 on the top and the bottom in order to make them match. So what I actually have is 4 plus 3 bracket p minus 1 all over p plus 1, p minus 1, which is going to give me 4 plus 3p minus 3 over p plus 1, p minus 1, or 3p plus 1 over p plus 1, p minus 1. I can't factor down the top, so I'm just going to put brackets to show that I can't factor that down at all, and state that this is going to be when p cannot equal 1 or negative 1. You can also just use, if you want, the p cannot equal the positive or negative 1 if you want to simplify that. All right, in the second case, I'm going to factor down the left-hand side, and I'm going to use my negative rule to rearrange the left-hand side. So I'm going to state right from the get-go that 1 over negative a minus 3 plus 1 over a plus 3, a minus 3. From here I can state that I have my non-permissible value. A cannot equal 3 or negative 3. And I'm going to wind up, because I pulled the negative out, it doesn't matter where on a fraction a negative goes. So I could have the negative on the denominator, I could have the negative in the numerator, or I could have it right beside. I'm going to wind up moving that negative up to the top up here so that I don't need to account for it in my denominator. And I'm going to state that the lowest common denominator is going to equal a plus 3, a minus 3. Which means that this one is going to have to be multiplied by a plus 3 on the top and the bottom. So from there, I can state that negative 1, a plus 3, plus 1 is all going to be over a minus 3, a plus 3. Or a plus 3, a minus 3, it doesn't really matter. And then I can state that negative a minus 3 plus 1 is going to be over a minus 3, a plus 3, or that negative a minus 2 is all going to be over a minus 3, a plus 3, and I can factor the negative out of both parts on the top. Negative bracket a plus 2 over a minus 3, a plus 3, where a cannot equal positive or negative 3. And there's my answer. For example, B. I'm going to start by factoring the denominators in both cases. And I'm going to say that I actually have 5 over 2 bracket a minus 7 minus 2 over 3 a plus 1. In this case, a cannot equal negative 1 or 7. My lowest common denominator well, between the 2 and the 3 is going to be 6. And then they're both going to need the a minus 7 and the a plus 1. Which means that for the first set, I need to multiply this by 3 and by the a plus 1. In the second set, I need to multiply this by 2 and the a minus 7. So what I actually have is 5 times 3 times the a plus 1 minus 2 times 2 times a minus 7 all over 6 a minus 7 a plus 1. Or 15 times a plus 1 minus 4 times a minus 7 over 6 a minus 7 a plus 1. I have 15a plus 15 minus 4a plus 28 over 6 a minus 7 a plus 1, or 11a plus 43 all over 6 a minus 7 a plus 1. I can't factor that down any further. I'm going to restate that a cannot equal negative 1 or 7, and there's my answer. For example D, I'm going to start by factoring the denominators once again. So I have x minus 1, well that can't be factored on the top, all divided by x minus 2, x plus 3. I'm going to subtract from that the x minus 2 can't be factored, but on the bottom, x plus 3, x plus 1. X in this case cannot equal positive 2, negative 3, or negative 1. The lowest common denominator is going to be, they all need a x minus 2, an x plus 3, and an x plus 1. They need all three of those different factors. Which means that the first one is missing the x plus 1 on the top and the bottom. And the second one is mixing the x minus 2 on the top and the bottom. So what I really have is x minus 1, x plus 1, minus x minus 2 times x minus 2, all over x minus 2, x plus 3, and x plus 1. Well, the top is just a difference of squares, so I'm going to get x squared minus 1, and I'm subtracting from that. The second one is a perfect square trinomial, x squared minus 4x plus 4. Don't forget that you have that negative sign on the outside, so leave this in brackets for right now. And it's all over x minus 2, x plus 3, x plus 1. So, if I have the x squared and I'm going to subtract an x squared, those two are going to cancel out. The negative of 4x is going to give me, negative of negative 4x is going to give me positive 4x, and negative 1 minus 4 is going to give me minus 5, all over x minus 2, x plus 3, x plus 1. I can't factor that down anymore, and I'm going to restate that x cannot equal 2, negative 3, or negative 1.